Let's continue our unit on modeling data. 9.6 is called Making More Money, where we're going to take a look at some scatter plots, comparing how much men and women earn, and we're going to estimate their correlation coefficients and their lines of best fit. And we'll also compare the calculated results of those linear regressions and the correlation coefficient to help us make predictions. So to start off, let's take a look at the data that we have. We're comparing information from the U.S. Census Bureau. They have income statistics for the United States in the years 1990 through 2005. They've provided the data in the tables below. All dollar amounts have been adjusted for the rate of inflation, so they're comparable from year to year. So we've got 91 through 2005, the median income for all men, and the same thing for all women. So I'd like you to create a scatter plot for the men, and also one for the women, and estimate the correlation coefficient. And so in doing so, I'd like you to, so this will be our X value, and this will be our Y value. And let's measure our X in years since, so it's easier to see on the graph. Anytime we have years, it's easier to measure in years since. So since it's from 90 to 2005, let's go years since 1990. And let's do the same thing for men and women. So you'll make those scatter plots. You can do that on your graphing calculator on Desmos. And then estimate the correlation coefficient. What do you think it is? How closely correlated is the data? And then you can calculate the actual correlation coefficient. And then answer the questions what that tells you about the relationship between income and years for men. Does it have a positive correlation? Is it strong? Is it weak? Is it negative? And then compare the women and the men, their data. So I've got a link for you on Classroom and on the website where you can type that in and use the regression information. So go ahead and do that, type that in and answer questions 1 and 2, and restart the video when you're ready to go through that. Okay, so you calculated the you predicted your correlation coefficient. The actual correlation coefficient for the men was 0.793 and for the women was 0.964. Hopefully you got pretty close to that. When you made your scatter plot, the men are in green here, and I guess the women are also in green. Change that color. But what we have is the men and the women. We can see that the men are kind of going up, but then it's for a while it goes up and then comes back down. Whereas the women seem to always be going up, so that's more of a correlation with that. It's a stronger correlation than the men. So either way, you should have predicted that the women had a stronger correlation than the men. So as we take a look back at here, whether you predicted it right or not, it tells us that the women have a very strong positive correlation. Men, there's positive correlation, though not as strong. So we would be more apt to predict the women's than the men's, according to our, if we were able to create an equation. So that's what the next part asks us, is to estimate and draw a line of best fit for the data. So on your own, you can go ahead and kind of figure out where that line of best fit is going to be. But remember, when you're drawing a line of best fit, you're trying to get it to fit most of the data. You got to try to figure out, where am I going to go? Do I start at this point as my start and finish there? Kind of connect those. Because when we draw a line of best fit, we're trying to get about half the points above, half below. So maybe that's a good fit. Where's another good fit for this one? That looks like a decent fit. So, you can see that this one, the points correlate a lot closer than, let's say, this one. It doesn't correlate very strongly to a line for the men's equation. We're going to skip over number 4 for now, since technology helps us with that, creating equations a lot better than our lines of best fit. But you'll work on your own. See if you can come up with a better line of best fit than mine. And we can talk about how you chose that in class. The next thing I want you to work on is create the linear regression. And that you can do on Desmos. And we can take a look at that. But then I'd like you to create those regression equations and then talk about what the slope means in units, in terms of units. What does the y-intercept mean? Compare your regression lines for men and women. And what does it tell us about their income? And then what do you estimate will be the median income for men and women in 2015? So use your regression equations. So go back into Desmos and use your regressions and your lines of best fit in order to come up with those and make those predictions. So restart the video after you've answered those questions. Okay, so to help us figure out our regression equations, we just go to our regression after our table, and we plug in our M and our B for both men and women. So in that case, I've got my equations listed there. Hopefully you got a very similar equation. And as we take a look at what the slope means, well, it means how much we're increasing our y for every x. So $311.60 increase for every year. Same with women, $464.10 increase every year in the median salary. What does the y-intercept mean? Well, that stands for what it was when we started. What's the median salary in 1990? And you can see the values for both men and women. And as we compare those regressions, we see that the women have a higher increase. Both of them are increasing, but women are increasing quicker and more per year. But the men started with a higher median salary in 1990. Now, how to make the prediction in 2015? Well, there's a couple ways we can do that. Those are the values that I found. One way is to use your regression equation. So use the regression equation and plug in your value for x. So for years since 1990, that'd be 25. So plug in 25 for x and solve for y. Or use your graphing calculator, and we can just use our regression line and figure out when x is 25, what's our y value. You can see that it's 29,655, and for men it is 45,421. So that's how we can use that regression equation to help us make predictions. Next, let's take a look at final few questions here. We're going to add some data from 2006 to 2011. With the addition of that data, what would we now estimate the median income in 2015, and why? And how appropriate is the linear model for the added data? So go back into your graphing calculator, and you're just going to add the new data. So now we're going from, where's our men here? The men, so in year 16, we had 41,103. So go ahead and enter the rest of the data and see how your equations change. Restart it when you're ready to take a look at it. Okay, so as we add the data, you can see the trends in the graph and the new line of best fit. As you see your line of best fit, we kind of notice that kind of splits the points. About half are above, half are below. And that's kind of what happens when you create a line of best fit. We're going to take a look at that a little bit more in the next lesson, how that works. Same with the women's line, about half below and half above the line. Notice when we added our new points, we start to have kind of a downward progression. This one kind of went up, then down, and now it's going back down again. So as we take a look at that and we predict what it would be in year 2015, we see the values are a little bit lower because their line of best fit dropped a little bit. Women seem to increase a little bit. And those are the values that we came up with. Notice what we had before, 45,000, 29,000. I guess I was wrong, they both dropped. So men were about 40,000 now, women 26,000 based off the recent trend of the dropping values. But as we take a look at those, notice, are they really a good fit? Notice the men's line. The R value is 0.165. We can see that that's not even close. It doesn't go through any points. And the points look like they're going down now. So we can't really extrapolate the data. That means use what we have and go beyond to make predictions very well, since it's not very closely correlated. The women one is a little better with their correlation. It's 0.878. So we could be more confident, but we see this final downward trend, and we would think that, well, maybe it's not going to keep rising as it is. So it'd be harder to make place a lot of confidence in that. So I had put that down on question 11 there. How appropriate is the linear model? Well, it's not very appropriate because, well, first of all, the men's correlation coefficient is very low, but then the women is starting to decrease again. It doesn't look like it's going to continue that upward trend. So that's all the time we have for that. In your homework problems, I'd like you to skip problems 1 through 10. There's some typos there in this graph here. So let's just skip all this. And you can do the scatter plot and try to find your line of best fit for 11 through 14 here. And then determine which of these models are going to be the best for making predictions. And then also review what you know about arithmetic and geometric sequences and how to create those explicit functions. So if you need help, look back in your notes in that section as you go through that. Okay, that's all the time we have. I'll see you in class.